Let's see, number 11 in the lecture examples wants to know how many atoms. So we will stop when we get to number of atoms. You would have, if there were 130.8 grams of zinc. Now, grams does not directly relate to atoms. Grams can relate to moles, and moles can relate to atoms. So this is going to be a two-step problem. Anytime you read something and it gives you grams and asks about atoms, or it gives you atoms or molecules or formula units, and then it asks you about grams, it's going to be two steps. You're going to have to convert to moles in the middle, because moles is what connects grams to numbers of particles. So first I need to convert grams of zinc to moles of zinc. So that means 1 mole is going to be on top, and 1 mole of zinc, if I look on the periodic table, the atomic mass of zinc is 65.38 grams. So 1 mole of zinc is 65.38 grams of zinc. Now, since I want number of atoms, comes step 2. And I know that there are 6.02 times 10 to the 23rd atoms in 1 mole of anything, but zinc is what we're interested in right now. And then I can punch that in a calculator and find my answer. So you can do this one of two ways. You can multiply all the way across the top, multiply all the way across the bottom, and then divide those two numbers. You can do each step along the way, so you could do 130.8 divided by 65.38 times 6.02 times 10 to the 23rd, and then get your number of atoms. Now, I'm a big fan of estimating before I do any math, so 130.8 divided by 65.38, that's going to be about 2, right? Or right smack dab on 2. And then 2 times 6.02 times 10 to the 23rd, so that's going to give you 12 times 10 to the 23rd, or 1.2 times 10 to the 24th. Everything here, 4 significant figures, 4 significant figures, 3 significant figures. So we're going to report our answer to 3 significant figures. Grab our calculator, and 138.8 divided by 65.38. So that means we're working with 2 moles, and then multiply that by 6.02, 10 to the 23rd, and the calculator reports it as 1.204368. If I'm going for 3 sig figs, then we're going to grab those 3, 4 rounds down. So our answer that we're going to report is 1.20, and that was then times 10 to the 24th atoms of zinc. Might as well go on. We'll do number 12. Number 12 wants to know what is the mass in grams of 3.76 times 10 to the 22nd atoms of mercury. So it asks for mass in grams, so when we are finished, we're looking for grams of mercury. It's going to be the exact same but backwards. We need to convert atoms to moles, then moles to grams. 1 mole of mercury is 6.02 times 10 to the 23rd atoms of mercury, multiplied then by 1 mole of mercury for every, what is mercury's molar mass? I did not write that down. It's like 200, right? 200.6-ish. You should have a periodic table. I should have a periodic table. 200.59 grams of mercury is 1 mole of mercury. So that means moles of mercury will divide away, atoms of mercury will divide away. So we've got 3.7, let's call that 4. So 4 times 10 to the 22nd divided by 6.02 times 10 to the 23rd times 200.59 equals our grams of mercury. This number has 3 significant figures. This number, 3 significant figures. This number has 5 significant figures. So our answer will only keep 3 significant figures. So 4 divided by 6, that's 2/3. 10 to the 20, so that's 1/10 of 2/3 times then 200.59, so 1/10 of 2/3, so that's what, 6% of 200, so that should come out to be about 12 grams of mercury. So punch it in that calculator, 3.76 times 10 to the 22nd divided by 6.02, 23 times 200.59, and the calculator tells us that it's 12.5285. We said 3 significant figures earlier, right? So 12.5 followed by a 2 that rounds down. So the answer here would be 12.5 grams of mercury.